right, this is the second and last video for section 3.3, composition of functions. You guys, I have to tell you, I started this video wearing my mask. I'm alone in a room. Don't need to do that. So if I sounded funny, it's because I was masked up. All better now. All right, so this video set, we are, it should go fairly quickly. We have a spicy set of composition of functions to do where you are given your functions in function notation. And then we're going to look at how do you handle composition of functions when you're not given the function but you're given a graph. I actually like these a lot better. I think they're kind of a lot more fun. But that's my opinion. You'll see what your opinion will be. All right, so in your notes, you're copying down our spicy example. K of x equals 3x, and R of x equals 2x plus 1. There's lots of x's going on here. And then the compositions we're going to work on are K of R of x and R of K of x. I'm hoping you're noticing the difference between the mild and medium problems, that in this spicy one, the x doesn't have a value. Like that x in the middle, you want it to say 4 or 7 or 3 or something you can plug in, but all we've got here is x. So I want you to know how to handle that. The approach will be the same. It's really not too bad. The approach is the same in the sense that we work inside out. So to solve a problem like this, I would just like before, the K with the parentheses, and then, well, R of x, what is R of x? Oh, it's 2x plus 1. In our other examples, we put a number in for x and we were able to simplify. That's not the case. We don't have a value for x, so we can't simplify. So the best we can do now is K of x, well, you take this whole thing right here and put it in for the x up in K of x. So we've got to do K of 2x plus 1, you use what the K of x is, 3 times x. Every time we see that x there, it gets replaced with this 2x plus 1. And then what we can do is simplify it just a little bit by doing the distributive property and get 6x plus 3. So if this was in our table of values from the last video, R of x would have been the answer to the first column. 2 of x plus 1 is that answer in the middle column that we use to get the final answer. So you would say K of R of x equals 6x plus 3. All right, let's try going the other way around. R of K of x. I'm going to put the R with the parentheses so I don't forget I have to do that second set. And now I'm going to write in, well, what is K of x? It's 3x. That's as far as I can go. That's as far as I can simplify. So now to do R of 3 of x, I'm going to plug it into the R of x equation. So in 2x plus 1, every time I see an x, I replace it with that 3x, and I simplify, and I get a 6x plus 1. So in a table, the K of x was the first guy. The 3 of x was that middle answer that helps you get to the final answer of 6x plus 1. So R of K of x is 6x plus 1. All right, so there is your third example of composition of functions when you're given the functions in function notation. Let's talk about what you do when you have these graphs. It is definitely worthwhile for you to take a minute to sketch these out. The first one is labeled as f of x. The second one is labeled as g of x. These functions are in, well, f of x is in the first and second quadrant. It has a point at -1, 1, goes down through the origin, and stops, let's say, at 2, 4. So there's important points at the origin, -1, 2, and 2, 4. Have that in your notes. G of x, it's just a line segment with one end at 1, 1, and the other end at 5, 3. And I would say there's an important point at 3, 2, right there. Okay, functions. These look really familiar. I like them. We've got numbers involved. We're gonna work inside out, and let's see what's going on. So to work inside out, g of f of 1, well, so to do this guy right here, f of 1, we're gonna look at the f of x function, and remember, that number is the x value. So in this case, x equals 1. So what's going on in our graph when x equals 1? Oh look, y is 1. So f of 1 is 1. Now, so that's like our middle answer. Now g of 1 is saying, okay, well, in our graph g of x, so this one right here, when the x value is 1, what's y? Oh, it's 1. So g of f of 1 equals 1. We're like, this was the first number, and then that was the in-between number to get our final answer of 1. All right, how about f of g of 3? I'm going to put the f with the parentheses so I don't forget I have to do it. But to find g of 3, well, now x is 3. We're going to look at the g of x graph. So what's going on? When x is 3 on the g of x graph, our y value is 2. So g of 3 equals 2. So now to finish this problem, it's saying we'll find f of 2. So now we're going to look on our f of x graph. When x is 2, what's going on with our graph? Well, y is 4. So it looks to me like f of g of 3 equals 4. We started with 3, plugged it in to get our middle answer of 2, and then we were able to get our final answer of 4. And then finally, g of 5. This one's kind of fun because both the first time and the second time, we're just going to be using the g of x graph. So what is g of 5? So on the g of x graph function, when x is 5, it looks like y is 3. So now we have to find g of 3. We stay on the same graph, g of x. When x is 3, y is 2. So g of 5 is 2. So visually, given the pictures or the graphs of functions, that's how you can solve for compositions as well. Continue to go inside out, and you shouldn't have a problem. That's it for today.